Hello everyone, and welcome to today's webinar with Andea, looking at utilising AI for inline diagnostics and repairs. Before I introduce your speakers, I do have a couple of housekeeping points. So there will be time at the end for questions. And if you'd like to ask a question, you can use the Q&A tab to the right of the slides on your screen. You can also use this to let me know if you're having any technical issues, and I'll do my best to help you out and get you connected. Your speakers today are Tadeusz Diduk, VP of Innovation from Andea, and James Montgomery, Director of North American Manufacturing, also from Andea. And with that, I'll hand over to James for the start of the presentation.
Lovely, thank you. Thank you again for joining us. Like we said, like Josh said, we're here with Tad. We're going to talk about utilizing artificial intelligence for inline repairs and diagnostics, and it's all built on Andea's manufacturer's platform as a whole. So before we start, I'd like to give you a little brief introduction about Andea, so you see where we're coming from and understand our pedigree a little bit. Andea was founded in Krakow, Poland 7 years ago, and it's kind of our main headquarters. As you can see, since inception, we've had significant growth year on year in both in the number of employees, but more importantly to us, the number of customers or partners that we've created along the way. 4 years ago, there was an office opened here in Brea, in California, that's where I work, and was open to us to support operations in the North American region. We specialize in global manufacturing, execution, and we have customers in 4 different continents. A little bit about that. Again, I don't want to go too long. I want to get into the meat of it, but we specialize in implementing manufacturing execution systems for global manufacturers. Coming up with that core solution, which not only works for a single site or a single area or a single line, but for be completely ubiquitous and deployed across the entire enterprise, and make sure it's not only can be run, but can be deployed, maintained, and enhanced on a global scale, which is challenging, but in our experience yields the best results. And when done right, it really allows for complete enterprise transparency and for sharing best practices at scale. We don't just do production systems. We do what Gartner calls MOM solutions, which stands for Manufacturing Operations Management, which includes solutions which include and synchronizing parts of many types of the business, including not only production but warehouse, quality, supply chain, and maintenance. We have completed over 440 of such projects, and when we talk about projects, these are 6-month projects, big projects. So, and we really wanted to learn from our customers. We really like to learn and gain knowledge from it. And when speaking to our customers, we kind of ran a bunch of questions about what are you constantly hearing and frequently challenging you in today's market. And I think, Tad, you're going to talk a little bit about that on the next slide.
Mm-hmm. Yes. So as we were working with these customers, there are certain challenges that come and appear frequently. So we have listed some of them here. They are typical drivers for MOM or MES projects. So starting with supply chain disruption, particularly recently with the COVID situation, I think that there's no need to explain what happens with the supply chain. And similar with the demand fluctuations, right? You can you remember maybe this scenes from US where people were fighting for toilet paper, for example. You can see some spikes in demand, and on the other hand, some drops very significant. So customers have to be very responsive to adopt to this market fluctuations. So therefore, they have to shorten their production runs. They have to be more agile, more responsive. Another challenge is, and this is probably one of the main drivers for many years for our projects, is to have sustainable quality and efficiency. So naturally, once you have a good product, you want to have a stable production, just continue increasing the efficiency, right? So you want to have predictability in your processes, right? So the sustainability is one of those key drivers for our projects as well. Similar with trying to lower the cost, right? So you can be more efficient if you can manage your processes effectively, if you can share information quickly at the shop floor between people, if you can quickly introduce new products to your shop floor, right? So you have to be able to pretty much share the information and track the information, feed it back to your ERP systems, for example. So these are, again, some key functionalities of MOM systems that allow lower your costs. Another advantage of MOM systems, or another challenge that our customers are facing, is the shortage of skills worker, and you can find it in different circumstances. For example, when you introduce a new product, you need to have the skilled people that can stabilize your processes, but later you want them to share their know-how with the other people. Or when you're onboarding newcomers to the company, you want to quickly ramp up their skills, right? On the other hand, when these experienced people are leaving the company, the last thing you want to happen is the know-how, the knowledge to live with the person, right? So you want to somehow keep it in the company. And again, if your processes are somehow supported with a system, there's less room for improvisation. There's less room for individual people and only their behavior driving how processes are executed, but rather the system is taking over or ensuring that the processes are stable. And so the system can be also used to share this processes or proper behavior across the shop floor. And finally, as we are, this is, I would say, a recent trend where people or companies, realize that there's only a certain level with the cost cutting they can go. So when they reach the level and there's this new competition from developing countries, for example, that can do the same but cheaper because of the labor cost, what they have to do is really think about changing their business model, right? So think about if you're producing commodities and you reach the bottom of your costs, right? And there's really not much you can go further. And so the idea that we see is developing on the market is companies, instead of providing these commodities, are actually providing services around these commodities, right? So I think we discussed with James recently an example of the company that is producing diapers for adults, right? So they said, well, there's just as little as we can go with the price, but instead what they say is, okay, we can offer a service which, for example, ensures that these diapers for adults, they are changed only when needed. So they put some additional software plus device in the diaper so they can monitor, for example, these diapers that need to be changed. So their customers are buying actually a service. The hospitals, for example, where these adults are using these diapers, they are actually using the service rather than buying a diaper, which again allow them to remain competitive on the market. So if you see, it's like a 10,000 feet view of these big challenges that we are facing and our customers are facing, and these are drivers for many of our projects, right? So MOM systems or manufacturing execution system, they are typically, those implementations are driven by some or many of these challenges because they help to overcome them. But we realize that by enhancing MOM system with an AI component, we can take it to another level. We can make it easier for the people who are using the systems to access information quickly, easily, intuitively, and also to contribute to the knowledge that is consolidated in this system. So we thought that AI might be a nice add-in that will bring or increase the value of the shop floor systems or many other systems as well. But in this case, we are focusing in our industry on MOM systems. So that's what we wanted to show you, is an example of how we can implement AI component and how it can bring more value to your existing systems.
And would you say, Ted, like as implementers, we're seeing like the time to make an impact in these areas when people are asking for it is becoming much shorter? Like, I don't know, maybe it's the Facebook, Google, Apple thing where people want these polished solutions that are big hitters, and it's becoming very challenging actually for us as implementers to get in there and make those impacts. And that's what we're trying to do, is keep up with the speed of innovation that people are expecting.
Yeah, exactly. You cannot afford to have a 1-2 year project, to implement at the shop floor, because during this time your shop floor may change or your business circumstances may change significantly. So indeed, this implementation of such system has to be also shorter. I think this is the right point about the introducing of new technology. It has to be more intuitive than it that it could be in the past because of the shortening time that we have for implementation, right?
And I think people's expectations are getting crazy. Like my previous life, Tad knows, I worked at SpaceX for 6 years, and some guy come to me and lifted up his phone and showed me a picture of the Domino's pizza tracker, and he goes, why can't you tell me when I'm getting my rocket built, when I can get my pizza here? Like, people's just expectations are getting like and the consumers as well. So we're seeing like we've really got to try and keep up and set expectations, but make sure why set expectations. We try to keep up as much as we can.
Yeah. So the shop floor systems are becoming more and more easier to adopt by the user. They have more functionality that is intuitive, and that's also some of the directions that we are heading with this AI solution here. Yeah, so this is, as I said, this is an example of the adoption of AI-driven chatbot, and at the shop floor. So just to give you a little bit of kind of context, of business context for Eno's application, that's the application that's the name of the application we are going to present here. Let's see, what's this life of the people at the shop floor, the maintenance particularly team. All right, so traditionally, if there's a downtime at the shop floor, the operator will call his supervisor will call the maintenance supervisor will call one of his engineers, will ask, what are you doing? Are you available? There's a machine downtime, go and solve it. And so they go, the maintenance engineer will go and investigate, do some diagnostics, go for spare parts, come back, fix the machine. In the meantime, there's a long time when the machine is stopped, right? So that's, let's call it a traditional way, or the legacy approach, but it's present in many companies still these days, right? So when we are implementing our system, MESMOM Plus system, one of the business goals for such a situation is to shorten the time between when the event happened and when the maintenance engineer comes and start working on the issue, right? So instead of one guy calling another and having this chain of communication through the phone, we can have an operator screen where he can just press the button, fill in a short description of the issue, particularly explaining the severity and maybe briefly what happened, and immediately pass this message to the maintenance team, right? And ideally, if you have the maintenance team using the same system, they can see this instantly on their device or on their phone. Maybe they receive a SMS message, and so they can quickly react to it. And if the system is a little bit more sophisticated, the system can prioritize and tell them what to do first, right? So if there are more serious issues, they will be attacked first. Yeah. And we thought, okay, so it brings a lot of value by itself by shortening this time. And we have number of customers who said, okay, just shortening this time, let's say by a few minutes, and on average you can expect here, like, I don't know, 5 to 10 minutes just on the communication, pure communication. You can multiply it by how many downtimes you have. It's a huge savings. But we thought, okay, we can do even one step further, because these maintenance people are typically loaded with so many things. You don't want to bother them when they are not needed, right? And even if you use the system to communicate, to prioritize, they still will look at it. They will have to assess who's the closest, who's going to pick the job, etc., etc. So we thought we can do one step further and actually make the machine operator more autonomous in the early stage of the issue. And the first thing you do when the machine stops, you have to do a quick assessment, right? What happened? Is there anything I can quickly do to just continue producing, to somehow mitigate the issue, and then lower the impact of this issue on my production, right? So is there a workaround maybe? Or maybe it's just as simple as just restart a machine, or inspect one item that is very frequently breaking, etc. So sometimes there are really trivial things, but if your machine operators are not experienced, they will not be able to do it themselves. So we thought maybe there's a room for this AI-driven chatbot that can mimic this maintenance engineer in front of this machine operator and tell him what to do. Okay, so that's the goal of the application. And here we have a short video that is actually showcasing this. Yes, I hope you can see. So first, let me just explain that this is an application for mobile device, because many of our customers, the workforce is already mobile. We notice there's this trend of instead of having this bulky screens just attached to a machine, you want to be more flexible. So using tablets, even if they are mounted or placed, you can always take them and move from one place to another. And similarly with phones, right? So this type of interaction ideally should happen with a device that is mobile, so you can interact with the system anywhere, not just in one place where the issue might be somewhere else where you don't have the screen, right? So that's the first thing. Second, what I wanted to show here before we move on is that it happens as a conversation, right? So what you see here is that quite quickly this text appears, but it's not because the end user is super fast in typing on a smartphone, but because he's using voice to text conversion, right? So the system is automatically converting the words of the user to a text that is passed to the chatbot, and chatbot is doing the analysis and responding in the same way, or just opposite, right? So displaying the text, but actually the end user can hear it. Because we are sharing this movie with you and you can hear me, you cannot hear the chatbot talking, but that's how it works pretty much, right? So I wanted just to give you this context that the first thing that we thought about doing here is to make it as intuitive, as easy for the people to interact as much as possible. Okay, so let's move on with the movie. So what happens here in the first stage is, the chatbot is trying to understand what is the issue and where is the issue. So just these are the two crucial questions you have to ask. And if you would be a maintenance engineer, you would always ask the same. So what happened? Where happens? What's the location, or what's the equipment that broke, right? So that's what the chatbot is doing. So that's the first, challenge. We'll talk about challenges later, but first, the chatbot has to figure out. And as you're in the conversation, you're not typing the code of the machine. We could use here, scan a barcode of the machine. That is also possible. But if you're talking, you cannot expect that the end user will read, like a, I don't know, 16-digit code, right? So instead, the chatbot is trying to analyze and find out what is really the machine that the user is referring to, and later what is the issue with this. In this case, it's a Packer 01 that that failed. Yeah. So here the operator is telling, okay, the machine is broken, but the system cannot find similar issue in the database, right? So what the system is doing, okay, your description of the issue is too vague. I cannot find something similar, or I cannot find just very few similar responses. So if the answer is too generic, you have to rephrase it. So again, it's similar to what the engineer would do. Would ask what happened, and if the guy says, oh, I broke something, the engineer, the expert in this case, will ask follow-up questions. That's what the chatbot is doing, is asking follow-up questions, asking the operator to rephrase the description of the issue. Okay, so here's the system has found, in this case, the system has found a similar issue and is proposing a potential resolution, and asking the operator to actually assess, does it help him or not? In this case, the operator is not satisfied with the answer. And so we're moving to the next step, which is, okay, if the answer is no, then what we can do is we can actually create immediately a ticket, right? So you're not wasting time that you already spent on doing this description of the issue, of the location of the issue. You can use the same information to create a ticket. So what the system is doing first is asking you, do you want to create a ticket? Yes, no. If you want to create a ticket, like, for maintenance engineers, it has to do a paraphrasation, right? So it has to summarize what it has learned so far, and asking the operator to confirm or maybe add something to it, because after this discussion, the operator might realize, oh, I have some more information. It's not presented on this movie, but he can also attach a photo, for example, of the issue, which is quite nice. The photo tells much more than some word descriptions, right? So he's doing the chatbot is asking, do you want to add something? Yes, I want to add a comment. The operator in this case is saying it happened already a few times, which is a meaningful information for the maintenance people. They're okay, so maybe there's somebody who already worked on similar issue. It happened several times, so maybe we have to think about a better resolution if it happens several times, or maybe we can use simply the same workaround we used in the past just to continue production in our, let's say, hot period for production. Okay. And then what happens is the system is asking, okay, what's the severity now? Okay, how important it is, because we don't want the maintenance engineer to come and work on the low priority issue, right? So as you see, it's all like there will be a manager actually thinking, okay, so how should I designate my maintenance engineer to which job they should be sent to do, right? So, and then at the end, the chatbot is asking, okay, are you happy with this? Oh, sorry, we're already at the end of the movie. And I cannot play it, but okay, let's stop here. At the end, just the chatbot is asking for assessment. So was this conversation helpful for you? Again, why? Because we want to have some lesson from it. Okay, we want to improve the solution. So what I wanted to show you here on this example is I think I spent like 5 minutes or more describing this conversation. However, in real time, it took 45 seconds, right? So think about this period that the operator will take to call somebody, ask for for maintenance engineer to come, how long it would wait, and then the maintenance engineer will come and probably ask similar questions. Here it is automated, therefore the system is collecting quickly this information. Sure, the operator, it may take him a little more to answer these questions than it was presented on the movie, but still you can see a significant reduction in time for diagnostics. So even if the maintenance engineer would come, there is already certain information about the issue gathered. We know the location, we have a description, maybe we even have a photo. So the maintenance engineer comes maybe with a spare part. Okay, so again, you're bringing a better information about the issue to the maintenance people, so they come prepared, and again they can shorten the downtime because they are better prepared to act on it. Okay, so that is an example of the application that we have developed. This application is right now in testing with some early adopters. We'll talk about it in a second, but I wanted to give you first a hint of how it really works before we talk about some of the technical aspects of how this solution is built. And I encourage you to type questions if you have any. During
Please.
Yeah.
Please.
All right, so what we have learned through this, we wanted to divide it in two parts. The first is, if you look at the solution from the architectural point of view, and both me and James, we used to be architects. We are still responsible for architecture design for many of our solutions. So we look at it as there are two major building blocks of the solution. First, you have to have a knowledge base, which is a source for this AI, for the chatbot to work. And second, you have to have this, interactive conversation somehow implemented, so you can share the knowledge with the maintenance person or with the machine operator. So we decided to divide now this the rest of the presentation into these parts, just to give you an overview how you can approach if you would be implementing this or similar solution at your companies.
Yeah, thanks, Tad. First of all, we've seen some of the people that are joining this webinar, so we hope our feedback or our challenges aren't insulting anyone, because there's some big hitters on this call. So this is just what we've seen. So please take that into mind. The first thing we've noticed when we implement a maintenance solution, or we go visit a company and we visit the maintenance department, they're often extremely understaffed. They have 20,000 odd pieces of equipment or assets, and probably anywhere from 5 to 30 people maintaining all of those. They're extremely understaffed, and all it takes is 1 or 2 critical events, and you take those staff out for 1 or 2 days while they're ramping up getting machines. Speaking of those machines, people think that machines are cookie cutter, like the same CNC machine is the same CNC machines. They almost always come different. There's different parts in them. There's different substitutes parts in them, one from different vendors. And as they're maintained over time, you pull parts off, pull parts on. They've got special tooling, and they don't even have special standard repair manuals. For example, we received one part in my previous life where they asked for the manual. It got shipped. The manual was from 1957, manually typed on a typewriter in German. It's a unique world out there. Tad, you kind of saw it with Tad, where they were drilling in and finding what was the equipment that truly had the problem. An example I have is like an oven. Is an oven a piece of equipment, or is oven a location which has many pieces of equipment underneath it? It's not an easy answer a lot of the times. Like an oven, for example, has the HMI screen. It has the burner. It has the valves bringing the gas in. It has a pump if you've got to vacuum out all the air in it. you have all the PLC information to load the data in there. All of these things probably will be maintained separately. So understanding what is truly the problem and what is the maintainable unit or piece of equipment can be very challenging. And speaking of those equipments, they're often in places where there's no network infrastructure. You could be in the port of Long Beach where there's nothing. You could be out in a field with a test stand. There's no network infrastructure. That means it's very hard to raise a ticket, and it's also very tough to record what you're doing. So having something that can talk to the cloud via your phone is very important, like you saw with Tad when he showed you that. What kills these guys, like really they complain, is when they get a call or they get a simple ticketing request that says machine is broken or machine is down. Well, that doesn't help them. They need to understand what it is. They need to be able to diagnose it early. What tools do they need? What spare parts do they need to bring? This really kills momentum, like Tad said. You save 2 minutes, 4 minutes, 20 minutes being out there and getting that machine up. It has massive benefits in today's market. Tad almost, and hit it at it again, right, Tad, with the amount of knowledge that is in people's heads when they leave, and you go, oh, well, that person left, we left, we don't know how to maintain this machine, or he fixed that machine. And whether you like it or not, these maintenance people, they kind of have their own babies, right? Like Joe, he does welding. Sarah, she does the CNC machines. Like people have that, they kind of gravitate to their machines, and the problem is that they're the expert and you call upon them. A, it creates a bottleneck. B, all that information stays, and it's very hard to expand out at scale. Whether we like to see it or not, duct tape and zip ties keep the floor running. You open the machine up, there's a leak on a pump or there's a leak on a hose, something smoking. You just use duct tape and zip ties to get it up and running, get the machine running, and you need to order the parts because lead times can be 2 weeks, 2 days, sometimes even 2 months, depending on the part. So those lead times can be significant. So having those duct tapes and zip ties and being able to make sure you're tracking that extra work is not only challenging, but essential in today's market, So we talked about knowledge bases. And this is what we wanted to talk about, is getting that knowledge into these knowledge bases, getting that information of what happened. What do we mean by knowledge base? Just real quick, it's this structured or unstructured form of information. This is commonly thought as a database or as a document repository. So examples of a structured thing is like a database with clean tables, like a ticketing or request system or repair system, right? An unstructured data source or knowledge base could be like standard repair manuals or operating manuals or anything in a PDF that's stored in like a document repository. You can also scan those, and Tad's going to go into that a little bit. But without a doubt, like Tad and I have talked about this a lot, the biggest enabler to AI, and it becomes the bottleneck, is knowledge management and having that good set of information that you're feeding it. Garbage in, garbage out, right? Knowledge is the fuel for AI. But with that, we've found a number of different requirements, and it's not just a simple case of just hooking up and, let me point it to this database and AI magically figures it out like Jarvis from the Avengers. It's just not like that. The transactions that you're seeing and the requests are often very incomplete or wrong. In fact, like even though this is in its infancy, we want to prove it in real world. So we've asked a number of our customers who really do help us and want us to succeed, have given us 2 or 3 of their databases. And we thought they were pretty good. But when digging into it, we found that one of them, 50% of the records were incomplete and another 75%. Fields were left blank, transaction were left open or not done. Like they just were. It was fixed. They just moved it along. The date.
Or very vague descriptions, right? So that's a common. You pick the reason code other, or you describe, like you said, a machine is broken. So this is the 75% of the data which is technically there, but it has zero business value for knowledge management system.
Yeah, or the results done say, why I fixed the machine, it's up and running, why update the system, right? We don't blame them. Again, they're understaffed, right? And that they've got to keep their hands on the part, not hands on a computer system, right? Like this information, like Tad said, is often in older systems, right? We go there and we think, we always think it's in this ideal state, but it's not. It's in our Access database. It's in a legacy system that's 20 years old, has tons of data that's unstructured. Most importantly, most commonly it's in Excel sheets. Like We joke around that MES stands for multiple Excel sheets. The last is the system itself is often incomplete. We don't mean that in a mean way, but the system is designed to either capture the problem, or it's designed to understand what was done and who worked it, and to track the genealogy of the work. Very rarely does it have both, or it's targeted at both. So having that solid knowledge base, again, is that fuel for your AI engineer. The cleaner the fuel, the better it works, so to speak. And what we've learned about capturing these knowledge bases and these information systems, or these request systems. Tad and I, how many have you done of these, Tad? I've probably done 30.
Not as many as you do, but yeah.
Yeah, and the biggest, and people are not afraid to tell you what they think, right? And the biggest feedback we get is, don't create a mortgage application for me. Don't ask me to fill out 30 fields or do all this crazy stuff, and don't error every time I save it because I haven't filled out this, and this. And, they're too heavy, and it doesn't encourage good behavior. So our thought process is, keep your request system as lean and as adaptive as you can. Try not to prompt for more than 7 fields. People are inherently good. Don't design around the weakest link. Make sure you encourage good behavior, encourage people from going into the system. The amount of ticketing systems on the floor, we go to some customers, and even some of the systems I had, the amount of request systems is completely overwhelming for the end user. You have a request system if you're a computer monitor, you have an IT request system, you have an asset repair system, you have if I need a part, if I need engineering, if I need quality, I need to go to a request system. If I have a non-conformance, I scratch something, I got to create one. If I want an improvement to the system or the system itself, I need, sometimes we go there, they have 14 to 16 different request systems. It's overwhelming. What we'd like to see is, and we've started to learn this, is don't even have a request base. Embed the request into the operator's screen, into their console, into their real world, and pass that context in there. Like you saw, Tad, if we could past the context of the work center or the machine that person's on, you don't even need a prompt for it. Try to reuse that information as much as possible. Trying to analyze free text fields is tough. So Tad's going to talk about how AI can help in that. It's definitely possible, but in the real world of things without AI, it's very tough to do analysis on these free text fields and understands what's happening. So you embed these categorization fields, like in maintenance is, what's the cause code? What's the repair code? Just to understand and categorize, what do I need to concentrate on? But be careful that don't spin the pendulum way too far. In one case, one of our customers, if they wanted to scrap a part, they had to choose between 1,000 reason codes to say why they scrapped that part. And what do you end up doing there, Ted? You choose
reason code other.
Yes.
Our winner of every Pareto analysis, right?
70%. And this really hit me hard, especially in my last job at SpaceX. I try to be as transparent as possible with my users, but they felt like these systems were black boxes, and they lost motivation completely straight away. They said, don't worry about creating a change request to enhance the system. It's a black box. They won't get back to you. And keeping that transparency and making sure the requester is notified and that you've seen it, and whether you have an automatic thing say, hey, it's been opened, or you have a trigger that sends an email or lets them know, or you commenting every 3 months and say, hey, we're looking at this is still a problem. Have a process where the requester feels heard and included, and that feedback is treated with respect, is very, very powerful. And that's a big life lesson I've learned, is make sure you treat feedback as a gift. Rewarding good behavior. We talked about bad behavior, but rewarding good behavior yields excellent results. At my last company, we created a feedback system where you could improve the process to say, hey, this is incomplete, there's too much tribal knowledge, the planning is wrong, this is a wrong location, what have you. You could create that feedback and send it. Well, the VP of manufacturing was a fantastic guy. He's the best person I've ever worked with in my life. What he would do, he would send out a newsletter every month and he would put the results of that feedback and say, hey, we want to shout out these people for doing a great job and making the vehicle or the process or this better. The day after he did that, the spike in feedback and resolved feedback was massive. It was over 20%. So that was really good. And that kind of leads on to that gamification, right? The gamification is real. We talk about it, we joke about it, but showing people want to do good things and they want to see how they're doing good things. And also people are kind of competitive and they want to be the best and they want to know they're doing the best. So putting metrics out there to show that really does help people. And speaking of doing good things, like completing the loop, leaving records incomplete causes pain. And the reason for that is they're not prompted to do it, and the system is very hard to do, right? Make sure you have ways that people get value out of that data. So make sure you have the proper analysis. Treat that BI or that visualization as a first-class citizen. I can tell you, I'm guilty of it more than anyone. I create a solution, or I embed it, and I roll it out, and I IT, and I send it to people, and then I kick it over to BI and say, hey, create the reports for them. No, that almost needs to be the end result, and that needs to be the center core, because that's the key information where people find out those nuggets of improvement. And again, AI can help with this, but giving people that visibility is so essential in moving it forward. And mistakes and life happens. The system needs to keep up. It needs to be a digital twin of real life. Things happen. People leave the company. People get promoted. People move departments. People sometimes don't have time to do their job. Make sure that people make mistakes entering stuff or closing stuff. Make sure you give the right people the ability to fix their mistakes in the system. But more importantly, try to automate as much as you can to keep up with that real life. Like if someone leaves the company, reassign their tickets to their supervisor, for example, or send them a reminder that, hey, these things, give bulk updates to say, hey, automatically close these out. Don't leave these transactions open. Because if you want to create a good knowledge base and a sustainable knowledge base, you need those mass updates and those tools to enable that, Next slide.
I think this is my turn now. So I think you quite well presented our lessons in building a solid knowledge base, and achieving this by itself brings you a lot of value, because on top of it you can run your reporting, your BI, and if you have a solid data in the system, if your reason codes are correct, if your descriptions are correct, if you have all the data, you can learn from it even using traditional tools, right? So you can have your, as we said, this Pareto analysis. If you have good classification in place, and if people are willing to actually provide this information, you can run standard reports and already have huge savings by improving your availability of your equipment, because we are talking about maintenance here, or generally just improving your processes, right? So it just these are practices for we could say generally any shop floor systems, right, that are collecting some information from people, right? So these are some good practices of how to build a system that can be a source for BI, for reporting, but also for an AI chatbot like the one that we have created. So right now here I would like to focus. Okay, so once we have this data, this knowledge that is gathered from the shop floor, these incidents, the description, the reason code, etc., how can we use it? And we thought, okay, so before we're not going to just throw it on the users. We have to build the whole front end for the people to interact with this knowledge, right? So first, we realized, okay, if we start building this ticketing system, we improve them. Initially, like James said, we have some customers where 50%, some other 75% of the data are incomplete. But we want to start with something, and in order to increase this critical mass of the system, so it has enough knowledge for the people to feel there's a point of interacting with this chatbot, because you have to start using it in order for it to actually be adopted and grow. We'll talk about it in a second. But so to create this critical mass, we realized, okay, we have to find another source of the knowledge, not just the tickets, right? And the other knowledge that, as you can imagine, is the documentation. You have user manuals for the documentation of the equipment at the shop floor. Sometimes there are some documents that are created by the maintenance engineers, for operators, etc. So we have a lot of these documents. They contain knowledge as well. Maybe it's not structured, like James said. This is this unstructured or not structured, an easy way, but you can use it, and we'll talk about it in a second. Second point is that the AI has to gain trust, and initially people will not trust it. They will have some hesitance to it, and you have to therefore position it well at the shop floor in the process, right? So you shouldn't assume, okay, AI will just give answers and people will execute it. That's obviously a mistake. But AI can provide these reasonable answers, let's say in 50, 70, 90% of cases. But there will be always this, this margin of errors for AI. So we have to prepare a process where this AI can actually fit and bring value, but the process cannot depend on the 100% accuracy of the AI. Next thing is, AI by itself. I mean, it's this catchy term, and we hear a lot in the internet about, oh, AI do this, or we see Tesla driving autonomously. Again, AI, right? So it's a catchy phrase. However, if you open the hood, the AI is doing a fragment of the solution. It's just delivering a part of it. Okay, AI is good in finding correlations, particularly in this case, because I mean AI can be adopted for different use cases. But in this one, AI is used to find correlation. What does it mean? It's finding something similar to what the user is asking for. That's all. Okay, but in order for AI to do it well, you have to do a lot of pre-processing of the data, so AI can be efficient in finding these similarities, and you have to find the whole. You have to develop everything around it for the end user, not to talk to AI directly, but actually to interact in this human-like conversation, right? So there's a lot of algorithms, a lot of development around AI, which is not using AI component, that still you have to do in order for the solution to work end to end, right? So to extract the knowledge and run this conversation with the end user when it's needed, find relevant information in the database, show it to the end user, validate it with the end user. If needed, do something else, then or close the ticket, right? So another thing is, if we would build this once, it would die. Why? Because the shop floor continuously evolves, right? Tickets or resolutions that were valid a few months ago, you reorganize the shop floor, you have new machines, so it becomes obsolete, everything that you had a few months ago, right? So you have to build in a life cycle for the knowledge base. And AI, or I would say broadly, this front-end application has a big value, or can bring big value in closing the feedback loop, right? So you can continuously grow your knowledge base or adopt it to new circumstances, so it learns, it grows. And we come here to the first topic. So you have to have this critical mass for the people to work with the system, so they can contribute to a further development and growth of the system, right? Of the knowledge base. And finally, James, you already mentioned several times that you have to show a value to the end user, right? They have to feel that even if the system is, or not feel that, they have to be sure that even if the system is not giving them the answer they were looking for, it was not a wasted time. Yeah. So one of this could be this just reward. Thank you for contributing to the knowledge base of the company. That might be one thing. But another thing is more just for them individually is, hey, since you already described everything, we can just use this information, not ask you twice, and just send it to the maintenance team. So this chatbot is actually combining several functions at the shop floor, not just advisory, but actually data gathering and sharing. Yep. So let's move on to our lessons learned for this part. Yes. So so as I said, ticketing system initially you have to build this critical mass. So we have decided to extract the knowledge also from documentation. So we have developed number of algorithms to extract this from documentation. It is not easy because documents have different formats. Not talking about different languages, their context varies. So the extraction of the knowledge from documentation, it's quite challenging, and we are still kind of improving here, but we have some good results so far. Another point is, as I said, the AI is good in finding correlation, but it's not self-efficient, right? So we have to do this algorithm. So what algorithms you need? To give you an example, if you take the ticketing system as a source of your knowledge, and let's say it's not in English. English is an easy language. I mean, comparing to Polish, for example, I'm from Poland. So in Polish, the same phrase have different tenses, so you can use, alternative, description of the same issue. I mean, not in any language, pretty much, but there are some languages where you have, special cases, etc., etc. So if you throw it on the AI, there's very little chance that two people, at least in Poland, will describe the same issue using exactly or very similar wording, right? So you have to denominate it to some common form that is easier for AI, because AI is just looking at similarities, right? So it's just, so we have to somehow convert it. So this pre-processing of the knowledge that is in the database from your ticketing system is crucial. And you have to do a lot of, algorithms, develop a lot of algorithms for this to prepare the data in the form that is usable for AI. And then you have the other end, as I said, for user interaction, right? So the AI is just this component, and you have to use it in a few places in your communication with the end user, right? So for example, the AI will be very helpful in figuring out what is the machine that the user is talking about. He's talking Packer broke. So the AI can say, oh, I have 200, I don't know, 20 Packers. I don't know which one. So the AI can say, no, you have to rephrase or describe it differently. Give me the number. Okay, so that's what the AI can help with. But you still have to have a whole flow of the conversation develop, where there's a logical sequence of the conversation, and AI is used in certain points. But then you have, standard, let's say, hard-coded algorithms that are doing, some decision points, right? So it's like a decision tree, something like that. Another point is, as I said, the AI hasn't yet gained the a trust of the people. It has to gain the confidence for edge cases particularly, and until then, the end users have to be put in a position when they take the ultimate decision, right? So the AI is just advising. Again, I love Tesla, so you may hear it many times today, but the way the system learns is because there's a driver behind the wheels who's controlling it. If the system decision is incorrect, the driver makes the correction, right? So it's similar here. Our chatbot is giving an advice, but it's the end user who's taking an ultimate decision and giving feedback to the application. This advice was good or not. Okay, so you have to put it in the position where this feedback is provided by the end user, and ultimately it's the end user to take a decision, because there will be always this, I don't know, 20, 30, 10, 5% of edge cases which are not documented in the knowledge base, or the system will provide an invalid advice or response.
And Tad, don't you think, like, I hate it when the AI hasn't gained your confidence, yet they act like it does. Like, I hate it when I'm talking to, like, I went to my bank to increase my transfer limit between banks, and I used that chatbot, and it was, you could obviously tell it was AI, but it was pretending it was a human being. I'm Catherine, and you could tell because its answers were cookie cutter, and it asked me for the same thing 3 or 4 times. It was honestly cheesy and cringy, and left me so frustrated that they would I felt deceived almost.
So you don't want to try it anymore, right?
I'm moving banks, man. That's maybe a little bit harsh.
Yeah, you're a very tough customer. James is triggered or alone. I don't know. Yeah, but so that's an example how you can lose an engagement of the end user. So the system just dies. It dies because it doesn't have this constant feedback from the end user. So you have to create this critical mass and keep people engaged, so they want to contribute, they want to use the system, and even if the answers are not correct, they can correct it easily. Like you said, it was asking you 5 times the same. That was probably something wrong with the interpretation of what you were saying. On the other hand, after 2 tries, you can ask just okay, let me transfer you to a help desk, right? Maybe that would be better customer satisfaction, right? Experience, sorry. All right, so let's move on because we are running out of time. The trivial knowledge, yeah, it changes, right? So the system has to self-improve. So there are actually 2 ways how you can continuously learn such system, or 2 major feedback loops. The first one is just to say this answer is correct or not, or maybe you can grade, or maybe if you have several answers, the user will pick the one that is correct. So this is like an instant feedback to the system to learn the neural network, right, from this feedback. That's number 1. And I would say that's quite obvious. And at the end of most call, I receive, for example, an SMS from some services. Are you satisfied with our service, right? So that makes sense, regardless if you have it automated through AI or just human-driven. But another, I think, equally or maybe even more important feedback is where you have those cases which failed, which are new, because this is the source for the knowledge base to grow. So you have to actually, you cannot just throw the ticket to the maintenance team in this case and ask them to solve it. You want the resolution to be completed and sent back to the knowledge base, so it will learn for the next time when similar incident happens to use it and advise with this in mind, right? So there are these two feedback loops that we realize that they are crucial, and therefore it makes a lot of sense to actually have it integrated with the maintenance ticketing system. Next thing is, people, and you saw it from the very beginning, people would rather talk than write. And I know it by myself. I would rather call our IT when I have a network problem than send them an email, because I know the guy, I can talk to him, he will solve it quickly. It's the nature of people. So yeah, why should we ask, like James said, to fill in a form if we can actually have this interactive conversation form and people are actually talking to the system? Sometimes it fails. There's no sure, the conversation, particularly in some noisy circumstances at the shop floor, sometimes you can lose some words. So in this case, you can always type, but if possible, we embrace the user to just, press the microphone button and just talk to the system and have this conversation-like mode. And finally, yeah, don't ask twice or 3 times the same thing. So if the system already knows a lot about your issue, cannot use it cannot advise you, at least use it and make sure this is complete. So you have the diagnostics, which brings a lot of value for the maintenance people. It can be shared with them, and you're sure that at least the issue description is not as stupid as the machine broke, right? So this is where the application can help. On the other hand, for the end user, he will see immediately the value, because he will say, oh, I already said it. I already provided the system with the information. When the maintenance engineer comes, he's not asking me the same. I didn't have to type into another system. It's there, they know it, they can handle it, and they can come prepared to resolve my action, resolve my situation quickly. Yeah, so these are the lessons that we have learned building the front-end part of the solution, this chatbot part of the solution that we wanted to share with you. And that pretty much concludes the session here. So we have some time here for questions. I would like to start with the first one, which is, what kind of data is used for setting up the chatbot? Actually, there are a few questions in one question, so I'll read one by one. What kind of data? So in this case, you have certain, I would call it master data and the knowledge base. So what is the master data? It's the context when you're building such solution. You have to take into account, okay, what are the machines? What are maybe some reason codes? So like a dictionary, right? You want to build it. And also when you're building this, we notice that it brings a lot of value if you build like a synonym dictionary. Okay, so we have the same word which can be described, the same entity can be described with different things, or the same, just using synonyms. It's clear, right, what I mean. But the other source is obviously this knowledge, which is extracted from 2 sources, from ticketing system, and that's very important long term. And initially, these documents which we can extract knowledge from them. So this is the data that we use. I hope it answered the question, the first question. Does the chatbot can communicate with systems like SAP to check how specific maintenance task has been completed, solved? Yes. So SAP, if you use PM module in SAP, it can be a source of the tickets, right? So you have reactive maintenance, and if you record the issue and the description. But what we have noticed quite frequently is you have some just ticket registered without the follow-up, what happened, how it was solved. But yeah, it could be a source of this of this data. I mean, you can use it as a source for the ticketing system. And yeah, I hope that it answers the question. I mean, you can think about pretty much any ticketing system that has these 2 crucial information: the problem and the solution, or problem and diagnostics, or symptoms. Yeah. because to give you more perspective, this solution not only can tell what to do, but sometimes at least can help with diagnostics, right? So it can tell you, okay, so potentially this is the issue, right? By asking about the symptoms, right? So, and again, it saves a lot of time for the maintenance engineer. When they come, they know, okay, most probably this is the issue, right? Okay, next question. Is the maintenance knowledge base the same as CMMS database? So
Okay.
maintenance database. If not, what is the difference between the two, and how do you envision companies maintaining both? I don't know, James, do you want to take this, or do you want me to?
I can take a little bit. Like CMS stands for like computer maintenance management system, and they also talk about, what was it, maintenance knowledge base. The answer is depends. In some cases, if you've got a very, very complete system, like you have Infor, Maximo, I've never actually used the SAP preventative maintenance module, or, you know, it could be both, right? You have many parts to maintenance, right? You have the preventative maintenance, you have the reactive or corrective maintenance, you have the predictive, you have the event-based maintenance, all that sort of stuff. You have some systems which have the feedback on how to make sure that you're gathering the information, or like what process or are you doing, you know, lean on the system to make sure that these machines are kept good. So the answer is kind of, it depends on the situation, it depends on the system, it depends what they're with that. You see that Tad said the more you can feed it, that's good. Like it could be like the operator manuals that you get from the supplier or you've built over time, they could be used. So the answer is it depends. I don't know, did you want to add something to that?
Yeah, I would say that, you know, the knowledge base can be based on the CMMS system. It can be extracted from it, or it can be also extracted from other sources. For me, this is like, you know, just extraction. And so it can be a part of the knowledge base. I would say in this context, the knowledge base is broader than the CMS database, right? So it can be a part of it, or it can be used to feed data to the knowledge base.
Yeah.
Okay, next question. Did you test your solution in production? So I mean, the solution is for shop floor operators. So in this case, we're talking about, you know, in which circumstances, or maybe what is the stage of the application? I don't know, but let's say I answer both. So first of all, where we are with the solution, we have two early adopters. We are testing with the real shop floor data. These are the examples that we shared with this, you know, 50 or 70% of, you know, data missing. This is coming from actual customers, because we have to, you know, scan through all this, you know, data that are out there. So we are before, let's say, formally making this, you know, live. We are still in pre-production stage, but obviously it's supposed to be used by the people at the shop floor. So that's what we are testing with real, you know, in real shop floor circumstances. Okay, and we have one other question I think we can answer. Does Eno work in offline mode? So I mean, this is this solution is hosted in the cloud, so naturally the knowledge is stored there in the cloud, and the logic is out there in the cloud. So what we can do on the device, we can collect issues, we can take certain, you know, description of the issues. However, the processing happens on site. So there's certain degree of capabilities which you can do offline. So you can record a ticket, you can describe the ticket, you can record it. But when you're talking about diagnostics or figure out what is the resolution, this happens only in the online mode. Yeah. Okay, I think we have reached the end. So I would like just to encourage you to, you know, visit us on LinkedIn, or see some movies on YouTube, or also join us on Twitter. There's a webpage, manufacturer.com, where you can see more about the solution, about what we do, also about the Enos. So you know, please contact us if you're interested, or if you want to be one of those early adopters. And yeah, you know, all the best. Stay healthy in these circumstances. I hope. Yeah, I hope to see some of you in real life. So that's all from me today.
Thanks, mate. Good job.
Josh?
He's ended it.
Yes. Okay.